Hello everyone, welcome to my channel. In this video, we will learn about interface segregation principle or ISP. Interface segregation principle is also known as ISP. This is another important principle of solid. If we see solid, SOLID, solid principle, this I stands for ISP or interface segregation principle. Let's understand what does it tell. It tells no code should be forced to depend on methods it doesn't use. That means we should not write any method which will not be used, and that method means there should be no force to depend on that method. Means it means that there should be zero non-used or dead code or dead method of interfaces. Okay, let's take an example of any button or view, whatever we can see in any website or any UI page. And let's say we have seen any submit button. What are the different types of action we can perform? One is we can click the button. Also another type of event can be on long press, that just click and hold and then lift your finger. So that is known as long press. Also in some cases we can change the position of the view. That is movement we can do. Drag and drop, those are movement related action. And also touch events. Means touch event is a combination of touch up and down. So these two type of that is also another type of event. So if I want to create interface for any view, and let's say that is action, the interface is, we can say, action listener, then what are the available methods, or what are the different methods that it can contain? Let's understand that. So we have written one interface, action listener. Ideally we were saying that this is for view action. So one method it can contain on click of view. Another method it can contain on long press. Okay. Then let's say we are saying on touch and on move, because we can drag and drop those things. So as of now we found this four functionality or four types of action it can contain. Now in most of scenarios, in button or any view, let's say my requirement is to use or implement the click event, on click event or on click method, but as it is of type of action listener, in my implementation I need to write, let's say I have written class view action listener. This is the implementation class. Okay, there I need to write the implementation of, okay, let's say the return type is void for all these. Void means we are not expecting any return type. So similarly it will be void on click, and the implementation will be on click, let's say perform login action or make network call. Those things we will write here. So to do action, whatever we want. Now as this view listener also actually we'll say it's implements action listener. Okay, listener, and then this one will be override, because we are override is the keyword it will come, because we are saying that we will implement on click method of action listener interface. Similarly, we cannot say this class is concrete until we implement all of the methods. That means we need to implement all methods, otherwise this class we can consider as abstract, it will not be concrete class. So in our requirement we found that we need to handle the click event of the button, but as this action listener interface contains 4 methods, for one we have written the implementation. That means for other methods we can say, let's say override, void, on long press. At least we need to give some implementation. Either it will be dead code, we can say, or dead code means no use or no code, where we can say it's no implementation, it's empty, or this thing we can write, or we can throw unsupported operation exception. So similarly I need to write for on touch method as well, and the same thing also I need to do for override, that void on move. Let's say in our case we are not implementing, or we don't want any functionality, so it's empty code we have written. That means in my requirement of button, in my calling environment, I know that I will call only on click event, means on click event will get called. That is, we can say it will be like new instance of view action, view action listener, then dot on click. This method will be get called, but not other methods, because other methods are not in our requirement. In button I want to only handle the on click event. So in that case, these implementation of these dead codes, or this become dead or useless, because it will not to be of any use. Similarly, in some requirement or in a few requirement, we will find that we need to handle on click event and on long press event, not other two. That means in those classes I need to only implement this on click method, and also I need to implement this on long press, but not other two, on touch and on move. Again I am forced to write empty implementation for them, and that will not be called from our calling environment, because our requirement was only to handle in that case on click and on long press. In those cases we found that we are forced to implement some methods which are of or which will not be used. Like in this case only on click method will be used, but others are not used. So this our code should not be forced to depend on the methods which it doesn't use, but here we are forced to write these methods, because it implements this action listener, and this action listener contains these 4 types of method. That is it is a violation of ISP. Then how we can resolve this? So here it tells the major thing is the middle word. First is interface. This is a interface. The middle word tells segregation, means segregate it based on the usage. So instead of creating one interface with all these 4 methods, instead of that we can create multiple interfaces. Like we will say that let's say one interface will be click listener. One interface is click listener where we can write only that void on click method. Similarly, another interface will be interface long press listener. Press listener void on long press. So similarly I need to write the other two interfaces. So based on my usage or based on my use case, I can implement multiple interfaces. Means I can write, let's say in my class view action listener, if I want to handle only one only click event means, and let's say I want to handle only click listener or on click event, so I will write its implements on click listener, and there I can write override void on click method, and I will implement that method. We will say implementation. I will write implementation for that, and no need for me to write other methods because this click listener have only one method, that is on click. Similarly, let's say in some use case I will need to handle or long press and click, these two. So there I can write click listener comma long press listener, and there I need to override both methods, that is void on long press. That implementation we will write here. So in this case, this is one method, on long press method, this is another on click method, and on long press method came from this long press listener, and this on click method came from this click listener. So we can implement multiple interfaces based on our use case or based on our usage. In this case, the benefit is that there is no method we have written which will be empty or unnecessary we are writing. But in our previous example where we have written all these four methods in one listener, there I have to give empty implementation. Here there is no empty implementation. That means my code is not forced to depend on any method which it doesn't use. It always knows that what are the methods I need to use, and it has only those methods, nothing else or nothing extra. So does that mean that one interface will have only one method? No. One interface can have multiple methods, but we need to ensure that all those implementations are really required to have. And we can say that we can categorize them as a group, or we can say the group of method which fulfills one type of action, and in our implementation we are saying that all those things should be there, all those implementations should be there. There should be no empty implementation, or then only we are saying that we should have multiple methods in one interface. But it should not be that one interface will have hundreds of methods. One class can have, but one interface should not have hundreds of methods. That definitely that interface will is very difficult, or we can say it will violate the ISP principle at some cases. Instead of that, it's better to segregate or separate the interfaces based on the its type or usage, And in this case, in our case, for this interface action listener, we can instead of that we can create four different type of interfaces. One as we created for click listener, similar long press listener, similar touch listener, and motion listener for move. And in this way we have separated. So this is this segregation of interfaces to smaller interfaces is ISP, where we are ensuring that there is no empty implementation or no useless implementation. Thank you.